So do you remember in the delta math last time where you made the tangent lines, like you turned the line so it was tangent to the graph, just goes by and hits one point? Today, the lesson is on learning how to write those equations. So you're going to write an equation of a tangent line. The reason those are useful is you can then use them to estimate actual functional values, as long as the point you're talking about is close enough to the point of tangency. And we're going to look at that in a second. But you have to remember how to write an equation of a line. We do go over this back in Algebra 1 and in pre-calc, but I'm going to just review point slope form really quick. It's y minus y1 equals your slope, x minus x1. I hope that rings some bells. We use it a lot. You don't have to rearrange it. You're allowed to just leave your answer alone. So I just made up an example there. I gave you a point and a slope, and we're just going to write our equation in point slope form. So for this point in this slope, and basically those are your ingredients and you're putting them together into the equation. It would be y minus which one of those numbers? Why the -8? It's the y value. Now, if it's minus -8, it would actually be +8. Good. Equals, and then what comes next? Your slope, so 2/3. And then what comes next? And it needs to be in parentheses. Good. So x minus 3. And that is literally the answer, and you'll just leave it alone. So I gave you the point and the slope. When we do these problems, you're going to have to get the point and the slope yourself, okay? And you need to remember, slope of a tangent line means derivative. Your slope of a tangent line is your instantaneous rate of change. Instantaneous rate of change. Remember Alice going for a walk, okay? And remember, I took that interval and we kind of zoomed in on one point and found instead of an average rate of change, like how fast was she going at that moment? So slope of a tangent line, derivative, instantaneous rate of change. Those all mean the same thing, okay? So here's our equation. We're going to write the equation of the tangent line. When it says write an equation of a tangent line, you need two things, a point and a slope, okay? So I usually set them up blank. And then it's sort of like a fill in the blank list, like scavenger hunt. You need to find all of these things and then you can write your equation. Now they have to give you something to get you started. And they gave you that x is 1. So our x value is 1. How do you get the y value? Plug in 1. If you plug in 1 for this equation, what do you get? Very good. All right, so we have our point. Go us. Slope comes from derivative. Slope comes from derivative. Slope is derivative. Most of calculus is slope, okay? So you're going to have to do limit h goes to 0 of the whole thing. Don't worry, you're going to do that a lot. You'll be okay. What's the first step? Plug in x plus h. So just basically recopy the function, but instead of an x, put an x plus h. Step 2, minus the function. This is basically just like more quiz review. And your delta math today, you're going to do this a few more times. So it's more quiz review. And then the whole thing is over h. So limit as h goes to 0. And yes, this is a twin. I would do it off to the side. That's what I call a margin problem. Off to the side, if you write it twice, you're going to get x squared plus 2xh plus h squared. You might want to just do well to like know that one. You do that so much. And what are we going to distribute into that? 2. So that will give you 2x squared plus 4xh plus 2h squared. Lots and lots of algebra. The limit is the only thing that makes it calculus. It's just lots and lots of algebra. All right, then what? Yeah, plus 1, and then distribute your negative. So minus 2x squared minus 1. We're probably all in different places at this point. Some of you are with me and some of you are done. All right, what cancels out? 2x squared. What else? Not yet. The ones, good. And then we're gonna factor out an h. And I guess, yeah, if you want to skip this step, like as long as your answer comes out right, I'm gonna give it to you, but you got to be really, really careful. So there were only 2 terms left. We factored out an h, and then you have to remember to plug in 0 for h. Its limit is h goes to 0. So what's our derivative? 4x. Very good. That's your derivative. Yay! Slope comes from derivative. Slope comes from derivative. What x value are we plugging into our derivative to get our slope? 1. If you plug in 1 there, you get 4. And from there, you just have to write the answer. I kind of ran out of space, so mine's going to go up here and it's going to go into part B. But this is your point. This is your slope. Those are like all your ingredients. Just put it all together. It'll be y minus what? 3 equals 4 parentheses x minus 1. So that is your answer. That's your equation. You just have to find a derivative. Yeah, it's not that much work. It's a lot of algebra. Now it says approximate f of 1.2. You got to get this part. So if you tuned me out while I was doing all that boring algebra, tune back in. The only reason we're allowed to use this equation to approximate 1.2 is because 1.2 is really, really close to 1. 1 is our point of tangency. If I were to draw a graph and then here's the tangent line, if you get too far away from it, do you see how it's not a good estimation anymore? You have to stay close to the point of tangency. So you could estimate for 1.2 or 1.1 or maybe 0.9. But if you get too far away from 1, it's not a good estimate anymore. Are you all with me here? I know we're tired and hungry, but you got to get that part, right? So all you have to do an approximation is instead of an equal sign, you're going to use the wavy equal sign, and you just have to plug in 1.2 for x, okay? So it's going to be y minus 3 is approximately 4 parentheses 1.2 minus 1. And you do have to get y by itself, because if you're approximating y, y has to be alone. But what's the only thing you have to do to get y by itself? Add 3. So y is approximately 4 times 1.2 minus 1 plus 3. You do not need to simplify that down if it's free response. So I suggest you don't. Now, if it's multiple choice, will you ever see this as an answer choice? No. So for the sake of us, say it was multiple choice and you didn't get a calculator and you had to actually figure that out, let's talk our way through it. 1.2 minus 1 is 0.2. Very good. 4 times 0.2. Well, what's 4 times 2? 8. So it'd be 0.8 plus 3 is 3.8. Let me talk you through that again. Just watch. 1.2 minus 1. 0.2 times 4 is 0.8 plus 3 is, again, that's an important skill to have, because if it's multiple choice, you'd have to get through that. Okay. Now, letter C, approximate 3.9. If my point of tangency is at 1, can I approximate 3.9? No. Where do you think I would need to rewrite my point of tangency? Why 4? Really close. So we're going to get a new point and a new slope for 4. If you're nervous about this, don't worry. We don't have to find the derivative again. Once you have it, you're good. Okay. I know you were all like, oh my gosh, we have to do that all over again. Now you have to be careful though, because you have a derivative and you have an original function up here. One of them gives you this and one of them gives you this, and you have to remember which one is which. How do I get the actual point? The original function. All right, 4 squared. 16, double that. 32 plus 1, 33. Slope comes from the derivative. So we're going to plug 4 into our derivative. 4 times 4, 16. And then you rewrite the equation. So we're writing a new tangent line equation at a different point of tangency. Okay, so what would our equation be? Y minus 33, 16 parentheses, x minus 4. And to do your approximation, all you're going to do is use a wiggly equals and plug in 3.9. And you have to get y by itself. So y is approximately 16 times 3.9 minus 4. And then what do I have to put at the end to get the y by itself? Good, it would be plus 33. I'm going to talk you through what that would be just for the sake of argument. If it was a multiple choice, you have to get through it. That's not going to be an answer choice. 3.9 minus 4. That's negative 0.1. With me? Negative 0.1. Times 16 would be negative 1.6. Negative 1.6. With me? So you have 33 minus 1.6. Well, 33 minus 1 would be 32. Minus another 0.6. 31.4. Was there a question back then? Oh, okay. All right. We're going to do one more with a new equation. Okay. So write the equation of the tangent line at negative 3. That means you need a point and a slope. And the x value is negative 3. Don't worry, the ones on the back are going to be less work, I promise. You're already looking ahead at it. I've got you. It's okay. Don't worry. So what's our y value? Plug in negative 3 to the function. Negative 1/3. Slope comes from derivative, and here's where you're going to have to do your limit. This is calculus. The other part was algebra. This is calculus. So what's your first step? Plug in x plus h. And then minus the function. And then the whole thing's over h. And step 4 is don't have a panic attack. Okay? I got a different color. Eyes up here. What is your common denominator between these two? X and x plus h. So you're going to multiply by x plus h in the numerator and the denominator. The point is to make it cancel. This is fun with fractions here. You're like, we're not having any fun this school. Negative fun. All right, so write your limit again. There's going to be fractions in the AP exam. Got to show it to you. All right. So when you look at the top part, we're looking at this right here. Just watch me point to this. You're going to take this that I made blue. You can't really tell it's blue, but you're going to distribute that through here. So when you take this and multiply it to the first part, do you see how the x plus h's would cancel? And all that's left would be x. Good. That's the first part. Minus. Now, when you distribute it to this, do you see how the x's would cancel and all that's left is x plus h? Very good. Fraction bar. And then when you do the denominator, it's just h times x plus h. Like it's just that. Now, hold on. We are going to get some stuff to cancel, and I am going to erase because I kind of ran out of room. What would you do with this negative first? You would distribute. So it would become a minus x and a minus h. And I'm sorry, I'm just erasing and fixing that because I ran out of room. So stuff does cancel, but the order is actually really important. What cancels first in the numerator? Yeah, the x's, x minus x is going to go away. So those are gone. Then what cancels? The h's. Okay, so here's our derivative. F prime equals, and this is tricky. What's still in the numerator? It's a negative 1. Because do you see how it was negative h? We canceled out the h's. There's still a negative there. That's really tricky. Okay. Over. What do we still have in the denominator? Oh, but we have to plug in 0. So it's just x squared. X times x is x squared. Remember to plug in 0 for h. So there's our derivative. Phew, we did it. Fun with fractions, guys. All right, what are we plugging into that to get our slope? -3 is your point of tangency. If you plug -3 into that, that would be 9. So your slope is -1/9. You have your point, you have your slope. Just put it all together. It would be y plus 1/3 equals -1/9 parenthesis x plus 3. And that went into part B. That's the answer for part A, but you know what I'm saying. Now, why are we allowed to approximate -2.8? Close to -3. What's an example of another number you could use? -2.9 or like -3.1 or something really, really close, okay? But all you have to do is plug this in for x and use a wiggly equals. So it'll be y is approximately -1/9 parenthesis -2.8 plus 3, just plug it in. But to get the y by itself, what do you have to tack on at the end? Yeah, you have to subtract the 1/3 over. I am not going to make you work that one out. We're going to just leave that alone. Okay. We will be able to finish these ones in the back. They'll go quick. Quick stretch. Good. Oh, go ahead. No. And this would probably be more free response. I can't really see them making you do something like that without a calculator. But they are evil, so you know. All right. I love chart problems. When you take the AP exam, if you see a chart like this, you want to be like, yes, because there is absolutely no arithmetic. All the numbers you need are right there. Okay. So all that like, oh, I forgot what is 7 plus 6 and your brain goes fuzzy. All the numbers are right there. There's no like math sort of. It's like pure calculus. All right. Average rate of change means what? Slope from 1 to 3. So don't be too proud to write out your points. It is algebra 1 slope. Now you do have to be able to read a table though. Which function does it say? G. So you need to look at the G column. That's this one right here. What is G of 1? -1. And then what's G of 3? -3. And then you're going to set up your slope, your difference quotient. It would be -3 plus 1, good, over 3 minus 1. That's your answer. All right. If you mess it up, it's wrong and the exam's timed, so don't bother. Now, if it's multiple choice, you have to figure it out. All right, when it says write an equation, you need 2 things. What are they? A point and a slope, and your x value is 2. Now it says function f, so look at the f column. What is f of 2? 7. Slope comes from derivative, so now you need to look at f prime column. What is f prime of 2? 5/4. Put it all together, and your answer is y minus 7 equals 5/4 parenthesis x minus 2. Don't you love the chart problems? It's pure calculus without any of the annoying algebra. Now this says approximate G of 2.1. That means you need a point and a slope. We're going to write an equation. Where should our point of tangency be? 2. Good. What's G of 2? You got to look back at your table. G of 2 is 0. Slope comes from derivative. What is G prime of 2? 10. Good. So put it together. Y minus 0 equals 10 parenthesis x minus 2. And to do your approximation, you will just use a wiggly equals and plug in 2.1. This one's kind of nice because you also have to get y by itself, but why is this good? Yeah, like you don't have to move anything over. It's gonna be y is approximately 10 parentheses 2.1 minus 2. For the sake of argument, 2.1 minus 2, 0.1 times 10 is 1. So that actually comes out to just 1. And then last one, where do you want your point of tangency to be? For estimating 0.8. 1, good. It's function f, so what's f of 1? 42. Slope comes from derivative. F prime of 1 is 2. Put it all together. I feel like at this point, like some of you are done with the problem already. Y minus 42 equals 2 parentheses x minus 1. And then you are just going to use your wiggly equals. Plug in 0.8. And what do you have to tack on at the end to get the y alone? Yep. Plus 42. If I made you work that out, do you think you could, in a multiple choice situation, get there?